Good morning, ladies and gentlemen. My name is Gordon Zulu. So we have this question here, which is interesting. It has two options. Find the minimum point for the curve, that one. So for us to find the minimum points, we will use the best confirmation. We will first solve for the first derivative, and we'll solve using the second derivative so that we confirm which point between A and B is the minimum point, because one can just solve and say, hey, I have my first option to be A and I feel to be correct. You get? Yeah. So we want to confirm which of the two between A and B is the best minimum point. So let us confirm. So we'll first find the derivative, where we know to say we have this one to be our derivative, plus 18x minus 24. So we find the critical values by equating it to 0. So we will have this as our expression. Then there is a number which is common here. If you check things out, there is a number which is common, and that number is -3. It is common throughout. So we will have x squared minus 6x plus 8 is equal to 0, where we find the product, sum, and factor. Where the product is 8, the sum is -6, and the two factors are -4, -2. So we'll replace x squared minus 4x minus 2x plus 8 is equal to 0, where we will have x minus 4, and also here we have x minus 4 equal to 0. So as having this, now we just collect what is outside and choose one bracket and solve for the value for x, where we have x is equal to 2 and x is equal to 4. So remember, I said if you are using the first derivative, you get these points and punch them in the original function. In this case, the original is y is equal to -x to the power 3 plus 9x squared minus 24x plus 26, where we'll just replace now our -2 in here, and we'll also replace with our 4. So we have our 4, we'll put, we see the resulting outcome. So we have done our replacements. Let's now just get our calculators and punch so that we see the value that 2 will produce and that 4 will produce. So if you compute, you will get your answer to be 2,6 and you will get your answer to be 4,10. And when you check on your options, we have A to be 2,6 and this one will be 4,10. You'll be like, how? Which one is now the minimum point? Is this question an error or not? Let's now use second derivative. We try to test more. We find more conviction to say, oh, it's A, so that when someone says A is your answer, you have support. So let's now go to second derivative test. So we now continue further by having this function to be differentiated twice. So we get y double prime -6x plus 18, where we will now get our critical points. At first we had 2, which is giving you -12, plus 18, which is giving you 6. And if you replace negative with that 4, it is giving you -24 plus 18. So -24 plus 18, in this case, it is -6. Where this one, remember we said is the maximum, where we said this one is the minimum. And look at the value which gave you the minimum. It is 2. So the best answer here, it is what? A.